Hello students, welcome to mathematics class. See, last class we learned increasing and decreasing function. Based on that dy by dx is greater than 0, it is increasing function. Dy by dx less than 0, decreasing function. If dy by dx is equal to 0, neither increases nor decreases. But another type of the same functions definition is the similar, but another type of functions. Let be an interval contained in a domain of a real function f is said to be increasing. We say that the function is increasing on this interval r, particular interval r, x1 less than x2. What? The points, how many number of points we consider? 2 points. If x1 less than x2, f of x1 less than or equal to f of x2. If what we consider the points, at that points we are substituting in the given function, and if it is first good in the form of f of x1 less than f of x2, such type of function we call it as increasing. Okay, either you can remember this or you can remember dy by dx is positive. Anyone you can remember. Next, strictly increasing function. If x1 less than x2, f of x1 is strictly less than f of x2. Just concentrate here, we are considering less than or equal to, but for strictly increasing only we consider less than. Okay. Next, decreasing on r. The reverse form. Naturally what we have done for decreasing, as x increases, y decreases. Correct. Similar concept we are using here. x1 less than x2. x1 less than x2 implies f of x1. f of x1 should be greater than or equal to f of x2. This reverse form will be. Okay. This is decreasing function. Next, strictly decreasing. x1 less than x2 implies f of x1 more than f of x2. Okay. Strictly decreasing. Decreasing, or else we can remember that dy by dx is less than 0. Okay. As x increases, y increases. Therefore, this is the condition also. As x increases, y decreases. Therefore, this is the condition. Therefore, any one condition you have to remember. Either use this or this. And both the type I explain. Take example based on this type. Show that the function f of x equal to 6x minus 3 is strictly increasing on r. Strictly increasing on r. Okay. Given example is f of x is 6x minus 3. Very first method, we know that how to calculate. How to calculate? This is dy by dx. 6x differential is 1, constant is 0. 6 dy by dx we got it is 6. Positive 6 more than 0. Therefore, dy by dx is more than 0. If it is more than 0, means it is strictly increasing function. This is one method. Just now I explained that method. If I take that one, we have tried x1 less than x2. Okay. Next, which is given 6. Therefore, multiply 6x1 less than 6x2. Next, which constant is there? Minus 3. Therefore, 6x1 minus 3 is less than 6x2 minus 3. If I take minus 3 both the side, what will it is? f of x1, correct? f of x is 6x minus 3. f of x1 is 6x1 minus 3 less than f of x2. Means we proved if x1 less than x2 implies f of x1 less than f of x2. Therefore, either use this form or any one method you can apply and simplify, but don't confuse. Both the methods I explained. Okay. Next, another one example I will take. Show that the function f of x is e to the power 2x is strictly increasing on r. Please remember that exponential functions e to the power x and logarithmic functions are always increasing functions. They never decreasing function, because see, the exponential function, the value of e itself is a 2.718 first one. Therefore, always it is a increasing function, and the log value is also more than 1. More than 1 means naturally it is towards which direction? Right hand value will get. Right hand value means always they are in the positive values. Therefore, remember that exponential functions and logarithmic functions are always increasing functions. By knowing this, now we will prove this one. See the solution by using the definition of the second type. X1 less than x2. Next, 2x1 less than 2x2. Next, take the exponential both the sides, e to the power 2x1 less than e to the power 2x2. Means actually we get f of x1 less than f of x2. Means we proved x1 less than x2, f of x1 less than f of x2. Means which form it is strictly increasing or I. Okay. Please remember that any one method you can apply. I will take next example. Prove that the function f of x is cos x. F of x is cos x. His first point mentioned, strictly increasing in 5 to 2 pi. Next, second point, strictly decreasing in 0 to pi. Correct. Next, neither increases nor decreases. In 0 to 1. Okay, this is the given example. The example is strictly increasing in 5 to 2 pi, decreasing in 0 to pi, neither increases nor decreases in 5 to 2 pi. We have to verify. Is it good or not? Solution. Given curve f of x is cos x, and that is y equal to, very first step is calculate the differentiation. Differentiate y with respect to x, dy by dx. Cos x differentiation is minus sin x. But very first step mentioned 5 to 2 pi. Given it is the interval x belongs to 5 to 2 pi in the open interval. According to ASTC rule, it is given 5 to 2 pi to 2 pi. This is pi by 2. This is 3 pi by 2. Okay, 5 to 2 pi. And mentioned this is sin x. This is sin value. In the third quadrant as well as fourth quadrant. Please concentrate. The value of sin in the third quadrant as well as fourth quadrant are negative. Therefore, dy by dx is minus of minus sin x. Did you understand? In the third quadrant and fourth quadrant, the value of sin is negative. Correct? Already minus sign is there. Minus into minus become what it is? Plus sin x. Correct? Plus sin x means what it is? More than 0. Means dy by dx is more than 0. If dy by dx is more than 0, we see that naturally it is increasing function. Therefore, dy by dx is 0 means it is strictly increasing function. Strictly increasing function. We can do like this. Okay. Next step. Next mention 0 to pi. Next mention x belongs to 0 to pi. Okay. This is 0 or 2 pi. 0 to pi. Okay. And dy by dx belongs to constant. For 0 to 2 pi, sign here also positive, here also positive. Means we can write it as minus sin x. Means we get it is minus sin x. Minus sin x means less than 0. Therefore, dy by dx less than 0. Less than 0 means it is strictly decreasing. Strictly decreasing. We prove on this interval. Okay, in this way we can calculate. Next, third one. See, in 0 to 2 pi, it is strictly decreasing. Pi to 2 pi, it is strictly increases. Therefore, 0 to 2 pi, complete circle. For complete circle, it neither increases. Means for 0 to 2 pi, it is neither increases nor decreases. Why? Because see, 0 to pi, it is decreases. Just now we proved strictly. Pi to 2 pi, it is increases. Means the continuation is not exist here. For continuation, if it exists, we can say that for 0 to 2 pi, we will get it is in the form of decreases, increases in this form. Therefore, we say that in the interval 0 to 2 pi, it is neither increases nor decreases. Okay, in this way we can do the example. And next example is given f of x is equal to sin x. F of x is equal to sin x. Is strictly increasing in 0 to pi by 2 mentioned. Strictly increasing in 0 to pi. Strictly decreasing in pi by 2 to pi. Pi by 2 to pi. Next, neither increases nor decreases. Neither increases nor decreases. 0 to pi. This is the given example. F of x is sin x. Okay, take the solution. Given function f of x is sin x. Correct. This is y equal to sin x. Do the differentiation. dy by dx. Sin x differentiation is cos x. Correct. According to ASTC rule, it is even 0 to pi by 2. 0 to pi by 2. Just concentrate. In first quadrant, we know that according to ASTC rule, in first quadrant, all are positive. Means cos is also positive. Therefore, dy by dx is positive. Correct. Dy by dx is positive in the first quadrant. Means strictly, it is strictly increasing. Correct. Strictly increasing in 0 to pi by 2. Next, think for pi by 2 to pi here. Okay, pi by 2 to pi, second form. Pi by 2 to pi. Please concentrate in the second quadrant. Cos negative. Therefore, we can say it is minus cos x. Means we will get it is dy by dx is less than 0. Less than 0 means naturally we say that it is strictly decreasing. In pi by 2 to pi. Strictly decreasing in pi by 2 to pi. Okay. Next mention 0 to pi. See, just concentrate here. For first quadrant it is increases. Okay. Second quadrant it is decreases. Means here in this case we can't get directly either it completely increases or decreases. It oscillates. Right? First half it is increases. Second half it is decreases. Means it does not get a particularly completely increases function or decreases function. It oscillates. Therefore, the function in the 0 to pi neither increases nor decreases in 0 to pi. Okay. In this way